Hey guys, I welcome you all to this session. Today we'll be performing data visualization with a package called as Seabourn. In the earlier live sessions of data visualization, we had covered the matplotlib library. Now I'll just wait for some of you folks to join and just give me a quick confirmation if you guys can hear me and if you guys can see my screen. So I'll just wait till then. And till the other folks join in, I'd like to inform you that we've launched a free learning platform called as Great Learning Academy, where we have near to 100 free courses. And these courses are with respect to domains such as artificial intelligence, machine learning, statistics, and digital marketing. And the best part is once you complete these courses, you will have a course completion certificate, and you can go ahead and add that certificate onto your resume or onto your LinkedIn profile, which will be a huge value add to your profile. So the link for Great Learning Academy will be available in the chat. You guys can check out the link for that. And let's say if you're someone who wants to learn from a phone, and if you don't have your laptop right now, we also have the Great Learning app. So the link for the app will also be there in the description. You guys can download the app as well. And also folks who are new to our YouTube channel, I'd request you guys to please subscribe to our channel and click on the bell icon, as it will encourage us to come up with more such live sessions on a regular basis. So I'm getting a lot of yeses from you guys that I am audible and you guys can see my screen. Okay, great. So now that this is clear, and I hope some of you guys are following our previous lectures. So in the previous lectures of data visualization, we had covered a lot of matplotlib. So in today's session, we'll be doing visualization with a package called as Seabourn. So Seabourn is a visualization library, and with the help of this, you can create various static graphs such as a scatter plot, line plot, box plot, pie chart, and so on. Now you can consider the Seabourn library to be a top level library which is based on matplotlib. So if you want to work with Seabourn, then you would have to also import matplotlib. So this is the name of the library over here. So if you want to work with this library, our first task could be to load this library. So here we are just typing import Seabourn as SNS. Once we load this library, since this is based on top of matplotlib, we would also have to load matplotlib over here. And from matplotlib, we would have to load the pyplot submodule, because with the help of pyplot, that is where we will be able to implement most of the graphs. So we'll type in import Seabourn as SNS, and then we'll go ahead and use the command from matplotlib import pyplot as PLT. Once this is done, so here, if you guys are new to Python coding, you must be thinking what is SNS and what is PLT. So these are the aliases. Instead of typing entire Seabourn or entire pyplot, I can just use a short form, because generally coders are very lazy and we would prefer short forms than using the entire name. So now that we've imported both of these libraries, it's time to load a dataset, and we'll be implementing a line plot on top of this dataset. So there's this method called as load dataset, which is part of the Seabourn library. So here we are just typing in sns.load dataset, and the dataset which we'll be loading is fMRI, and we'll store the result in this object called as fMRI, and then we'll just show the first 5 records of this data frame. So here we are using fMRI.head, and this gives us the first 5 records. So as you see, we've got 5 columns over here. So we've got subject, time point, event, region, and signal. Now out of these columns, we want to make a line plot. So a line plot in general, it gives you a relationship between two numeric variables. So here we've got time point, which we are mapping on the x-axis, and signal, which we are mapping on the y-axis. And most of the time series data, so as you see, this is a time series data over here. It is represented with a line plot, and since this is a time series data, we are using a line plot over here. So we are mapping this column called as time point onto the x-axis, and then we are mapping this column called as signal onto the y-axis. So as you see, we have time point on the x-axis and signal on the y-axis. And what we've done is we've mapped fMRI, which is the name of the data, onto this data attribute. So this line plot method takes in 3 parameters. Time point goes onto the x-axis, signal goes onto the y-axis, and fMRI is plotted onto data. And then we just go ahead and print out this line plot. So let's go to Jupyter Notebook and work with this. So here let me actually zoom this so that whatever I'm coding over here, that's clear to you folks. So first I'd have to import Seabourn. So here I'll type in, let me give in the name of this correct. So import Seabourn as SNS. And then we'd also have to import pyplot from matplotlib. So I'd have to type from matplotlib import pyplot as PLT. We have loaded these two. Now it's time to make a line plot, and to make a line plot we need the dataset as well. So we have the load dataset method inside this. So we'll just type in sns.load dataset, and the dataset which I'd want to load is fMRI. So here I'll just type in fMRI, and I'll go ahead and store this in a new object called as fMRI. Let me click on run over here. So we have loaded the dataset. Now let me have a glance at the first few records of this. So here I'll type in fMRI.head, and as you guys see, we've got 5 columns and we've got these 5 records over here. And this is the column which I'd have to map on the x-axis, and this is the column which I'd have to map on the y-axis. So I just have to use SNS, and the name of the method is line plot. So line plot is a method which is part of the Seabourn library, and with the help of this I can make a line plot. So I have 3 parameters over here. The first parameter is x, and onto the x-axis I will be mapping the time point column, and then I'd have to map something onto the y-axis. So I'll go ahead and map the signal onto the y-axis, and then I'd have to give in the data. So the data which I'm using is fMRI over here, and I just have to type in plt.show. So let me type in plt.show over here, and let me click on run. Let's just wait for the result to come in, and this is what we have. So let's say if the time point over here is in seconds, so this will go from 0 to 5 seconds over here. And as you guys see, from 0 to 5 seconds, the signal value is increasing exponentially. And from 5 to 10 seconds, the signal value is dropping exponentially. Right, so this is an interesting observation which you were able to infer from this line plot. And after 10 seconds, it sort of stabilizes over here. So it's sort of at the same level, it is stagnant. So from 10 to 17.5 seconds, it is, you can either call the line to be stagnant or it sort of stabilizes. So let me just see if there are any more questions. Shivangi is asking from where to get this data set. So this fMRI dataset is actually part of the Seabourn library. So you don't have to load this externally. All you have to do is import the Seabourn library, and this will be a part of it. Prachi is asking if there'll be a session with Python interview questions. So we will have that. So you guys can just register at Great Learning Academy. As I've been telling you guys, we have a lot of live sessions scheduled up, and so if most probably next week or next to next week, we will definitely have a session on Python interview questions. Dheeraj is asking, can you help me in what are the programs needed to start with data science apart from Python and R? So now Python and R are just programming languages. So you have to understand that data science is not just Python, or data science is not just R. These are just your weapons, or these are just your tools with which you can implement the data science concepts. So this is very important for a beginner who's trying to enter into the field of data science to understand. So if you just learn languages such as R and Python, and if you call yourself a data scientist, then that is not really how it works. So as I've been telling for all of my live sessions, there are basically three pillars. One of those pillars is definitely the programming languages, which are Python and R, but you have to take care of other two algorithms as other two pillars as well. So the primary pillar of data science is statistics. So you have to be really, really good at statistics, because it is what forms the base for artificial intelligence, machine learning, and data science. So if you're not good at statistics, then it'll be hard for you to comprehend most of the data science or ML concepts. So in statistics, you'd have to learn stuff such as central limit theorem. You've got measures of central tendency, measures of deviation. Then you have stuff such as hypothesis testing. This is statistics, and again, in statistics, you can also include probabilities. You can start to learn what exactly is conditional probability, and in conditional probability you can learn about Bayes theorem. Then you have different probability distributions. You've got the normal distribution, Gaussian distribution, Poisson distribution, and so on. So these are some things which you'd have to learn, and all of these form the base of ML. Now once you're good with this, then that is when you can actually go ahead and use these weapons of your choice. So your weapons are either Python or R. So I'd recommend you learn both Python and R, and you use these two languages to implement all the statistical concepts which you've learned. And once that is done, then you can go ahead and master all of the machine learning algorithms. When I say master the machine learning algorithms, you'd have to understand the mathematical concept behind them. Just implementing those ML algorithms with the scikit-learn library is that is that is again that is just a superficial stuff. So if you understand what exactly is happening in a linear regression algorithm, or if you understand the mathematical concept behind the logistic regression algorithm, then you'll be easily able to create most of the algorithms from scratch. Sunny is asking, can I get a job with data visualization? So that actually depends on what you want. So if you just learn data visualization with libraries in Python and R, then I'd say it's difficult. So there are actually BI roles. So BI is basically business intelligence. So these business intelligence roles mostly deal with stuff like either Tableau or Power BI. So if you are actually really good with Tableau or Power BI or MSBI, that is when so people actually look for folks. If you talk about data visualization, if you have expertise with either of these, and mostly nowadays Tableau is the front runner when it comes to BI. So if you have 100% expertise on Tableau, then you can definitely get a job as a in the data visualization domain. Shubham is asking, I'm learning data science, so can I get a job as a fresher in data science? So again, Shubham, once you master all of the concepts, you'd have to work on a lot of open source projects. You'd have to take part in a lot of data science contests. So what I'd suggest is there's a site called as Kaggle. I believe most of you have heard of Kaggle. You guys can go ahead and register on Kaggle. So there are a lot of competitions which go on in Kaggle. So you can team up with other members who are participants in the site, and you can work on different contests which happen over there, and you can improve your expertise. And also some of the companies are actually directly hiring from Kaggle. So let's say if you rank maybe in the top 100 in the world, then the companies over there actually directly hire you from Kaggle itself. So there are tags such as Kaggle Grandmaster, Kaggle Super Grandmaster. So that is something which you can work yourself upon. Gautam Sethi is asking, what is the prerequisite to learn Tableau? So as such, there is no prerequisite to learn Tableau. Tableau is very simple. It's all you have to do is drag and drop. To put it simply, it sounds very easy, but once you get the hang of it, and once you know how to, once you have the understanding of, which graph or which visualization technique to use when, how to combine these different tools, then it becomes really easy. So as such, to answer your question, there are no prerequisites to learn Tableau. It's just an independent tool in itself, and you can start learning it from scratch. Sajin is asking, can you explain about different kinds of plots and how it can be used? So I'll be covering that. So right now we've just used line plot. So we'll be covering most of the plots in today's session, and we'll see which plot is used where. Right, so I'll take up the rest of the questions later. And just to inform you folks, if you haven't yet registered at Great Learning Academy, please go ahead and register over there. So we have more than so we have almost close to 100 courses over there, and all of them are totally free. And so you either have to complete some quizzes, assignments, or projects. So once you complete them, you will have the certificate with you, and you can go ahead and add the D certificate onto your LinkedIn profile, which can be a huge value add to you guys. And also, if you want to learn through an app, we also have the Great Learning app, so you guys can register on that. And also, I'd request you guys to subscribe to our channel, as it will encourage us to come up with more such live sessions, and also upload more high quality tutorials. So please go ahead and subscribe to our channel and hit that bell icon over there. So we've done the first part, which was basically building a line plot. Now that this is done, let's go ahead and see what else can we do. Now there is another attribute in this line plot method called as hue. Hue, it basically is, you can consider this to be a synonym for color. Now let's say with the help of this, if we are mapping a column onto the hue attribute, then that column will determine the color of the lines. So over here, let's say if I go back, so as you see, we have this event column, and in this event column, we have two categories. So the first category or first event is stem, and the second event is queue. Now when I map the event column onto the hue attribute, since there are two columns in the, since there are two categories in the event column, that is why we'll get two lines. And since we're mapping this onto the hue attribute, hue is basically color, so both of these lines will have different colors. So here, as you see, the blue colored line, which is the stem event, and we have the orange colored line, and this orange colored line indicates the queue event. So this is how we can add colors to the lines. And let's say if I can actually just give it a general color, that is also something which I can do. But here what I'm doing is I am mapping a column onto the hue attribute, and since there are two categories, that is why I'll have two lines over here, and both of those lines will have different colors. So I'll just copy this command over here, and let me go ahead and paste it at the bottom. So this is the same command again. All I'm doing is adding a new attribute called as hue, and to this attribute I am mapping a new column, and that new column is event. And let me run this now. Let's just wait till this pops up. Right, so as you see, we've got these two events. So we've got stem and we've got queue. And as you see over here, so we have sort of an interesting observation. So from 0 to 10 seconds, if you see over here, then the signal value of stem event is higher. But from 10 to 17.5 seconds, you can clearly see that the signal value of queue event is higher. Right, so initially from 0 to 10 seconds, there's a huge difference. So the signal value of stem is very, very large. But then after 10 seconds, it's like drops very below the queue event, and the signal value of queue is higher than the stem event. So this is again an interesting observation which we were able to infer from this. So we are done with this. Now we can also go ahead and change how our lines look like. So when I say change how our lines look like, this is basically the style of our lines. So here we will use a new attribute called as style, and we are mapping the event column onto style. And again, as you see, since we are mapping a column onto this, So since there are two categories again in this event column, we will have two lines over here. The first line, which is blue, so this is a solid line, and then the queue event. This is being represented by a dashed line. So both of these have different styles over here. So this is again the same command. Let me just go ahead and copy the same command and paste it at the bottom. Now I will use this attribute called as style, and again what I'm going to do is I will map the event column onto style, and let me click on run. And as you see, we've got these two lines over here. So the stem event is being represented by a solid line and the queue event is being represented by a dashed line. So just some minor changes which we've done in the plot. Now once this is done, we can also add markers over there. Now when we talk about a line plot is basically, it connects the markers, isn't it? If you, let's say, look at this line, now you have this line because let's say over here there would be a point where, let's say, time point is 0 and the signal value is 0. Similarly, if you talk about this, you have this line over here because there would be a marker over here which would indicate the x and y value. Similarly, you have this because there will be a marker which has this corresponding x value and the y value. So line plot, essentially you are connecting all of the markers which are present, and by default those markers are hidden, and if you want to add those markers, all you have to do is use this attribute called as markers and set it to be true. And as you see, we have added the markers to this. So again, the markers, since there are two lines over here, the markers are different. So the markers for the stem event are represented by solid circles, and the markers for queue event are represented with crosses over here. And this is the only difference which we are making in the above plot. Now let me go ahead and add this new attribute. So all I'm going to do over here is add this new attribute called as markers, and I'm going to set this to be true, and let me click on run. Let's see what are the changes which we see over here. And as you guys see over here, so we have the markers. So initially we did not have the markers in the above plot, and in this plot, when we have set markers to be equal to true, we've got solid circles for stem event and we've got crosses for queue event. So let me go ahead and look at some questions. Paris is asking, I think I'll need to see the head output again. Sure. If you look at this, these are the different columns which we have, right? So we've got 5 columns. Initially what we did is we started off by mapping time point. So this is the column. We had mapped time point onto the x-axis, and then we had signal. We had mapped signal onto the y-axis. Now after that we had introduced this new event called as event, right? So in this, this is just the head, so you can only see the stem event. We have another event as well, which is queue. So what we've done is we have mapped the event column onto the hue, and since there are two levels or two categories in the event column, that is why we have two lines. Similarly, all we've done is we have mapped the event column onto the style again, and again we have set the markers to be equal to true, and that is why we have the markers. So I hope this is clear now. Paris is asking what are stem and queue. So stem and queue are basically these values which are present in the event column. Shweta is asking, is it possible to add many lines using queue? If not, how else can it be done? Now that depends on how many categories you have over here. So let's say over here in the event column we've got two categories. Now let's say instead of mapping the event column, I go ahead and map the region column. So I haven't seen how many levels are there. Let me just go ahead and map the region column onto this. So here what I'm going to do is, instead of event, let me go ahead and map the region column onto this, and let's see what is the result. So here again it seems that we have two regions. So we've got parietal and frontal over here, and that is why we have two lines. So the number of lines which you'll get, that is totally dependent on number of levels which are present in the column which you are mapping onto the hue attribute. I hope that answers your question. Shivangi is saying she's got an error over there, cannot cast array data from data type in64 to in32 according to rule safe. So could you tell me where exactly are you getting this error? I'll be able to answer it. Ganesh Kumar is asking, is there any source to study mathematical concepts of random forest SVM where a practical step-by-step explanation is given? Ganesh, you will find a lot of free resources. So again, I'd actually recommend, so we've got a lot of courses on Great Learning Academy where actually these mathematical concepts have been explained by professors such as Dr. Abhinand Sarkar. So Dr. Abhinand Sarkar's got his PhD from Stanford, and we've also got Dr. Professor Vishwanath as well, and Dr. Vishwanath also has his PhD from Madras University. So these guys are stalwarts in the data science industry, and they've been ranked among the top 10 data science academicians regularly. So you can find all of those, all of their lectures on Great Learning Academy. So they've comprehensively explained the math behind the concepts of most of the ML algorithms, and they've also comprehensively explained most of the statistical concepts. So you can just check most of the courses with respect to data science and ML which are there on Great Learning Academy. I believe that will help you to understand most of the mathematical concepts. Paras is asking, what is that surrounding area around the line? So this is now when you make a line plot, so there is a region of error. Now, just simply put, you can consider this to be a region of error. So you have something known as so what you have is, so these are basically if this is an ideal line. Now let's say if there is any sort of deviation, then that deviation is represented with this region over here. So let's say if we have a point over here, then this is the ideal point, but let's say this point could also be over here or over here. So this is the maximum deviation which this point can go from its ideal location, right? So this region over here, that basically indicates the error region of all of the points which have been plotted over here. Nirdesh, so as others have stated, so this dataset is already present in the Seabourn library. All you have to do is load the Seabourn library, and there's a method called as load dataset. So as you see, you have to use this method called as load dataset, and fMRI dataset as a part of the Seabourn library. You will be able to load this. Right. So this was line plot. Now we'll go ahead and work with a different plot which is known as a bar plot. Now a bar plot is generally used to understand the distribution of a categorical column. So line plot, it is mostly, so again since most of you have asked where is which plot is used where. So if you talk about a line plot, then it is used to understand the distribution between two numerical columns in general, and most widely a line plot is used for time series analysis, and that is what we had done in the earlier example. Now we have come to bar plot, which is the next type of visualization. So in bar plot, it is used to understand the distribution of a categorical variable. Now when I say categorical variable, again as we had seen in the earlier example, we had either we had the event column, we had the region column, so those were the categorical variables. So we can use the bar plot to understand the distribution of a categorical variable. So similarly here we have a new data frame. Now this data frame is not part of Seabourn. So this is a data frame which I have is an open source dataset which I've got from Kaggle, and I've loaded this onto Jupyter Notebook over here. So again, to read this, I would need the pandas library. So as you see in the earlier example, I had loaded the dataset with the Seabourn library, but to load this dataset, I'm using the pandas library. So here I'm using pd.read_csv and I'm passing pokemon.csv. So this is the name of the file, and I'm storing this in a new object called as Pokemon. Now that I load this file, all I have to do is go ahead and make a bar plot out of this. And as I've told you guys, a bar plot is used to understand the distribution of a categorical column. So here I am using this method called as bar plot, which again is a method inside the Seabourn library. And I have a lot of columns in this Pokemon dataset. So when we go to Jupyter Notebook, I'll show you all of those different columns. So here we have a categorical column called as is legendary. So this column basically tells us if the Pokemon is legendary or not, and we are mapping this is legendary column onto the x-axis. Once that is done, we are mapping the speed column. So we have a column called as speed, which tells us the speed of the Pokemon, and we are mapping it onto the y-axis, and data again. So the data set which we're using is Pokemon, and then we just show out the plot. Now 0 over here, 0 indicates that the Pokemon is not legendary, 1 over here indicates that the Pokemon is legendary. So there are two categories. And since there are two categories, that is why we have two bars over there. And you can clearly see that those Pokemons which are legendary have a higher speed when compared to Pokemons which are not legendary. So interesting observation again. So I'll go to Jupyter Notebook over here, and I'll go ahead and write in the commands which you had seen. So first I'd have to import pandas. So I'll just type in import pandas as pd. Now that this is done, I'd have to load the files. So here I'll type in pd.read_csv, and inside this I'll pass in the iris file. So here I'll type in iris.c. Sorry, this is the Pokemon dataset, actually not the iris dataset. So I'll type in Pokemon over here, and I'll go ahead and store this in an object called as Pokemon. We have loaded this as well, and then I'd have to have a glance at the head of this. So I'll type in Pokemon.head, and let's see what are the different rows which are present. So this abilities column just tells you the different abilities of the Pokemon, and then you've got against bug, against dark, against dragon. So these columns tell you how does a particular Pokemon perform against a bug type Pokemon. This tells you how does this Pokemon perform against a dark Pokemon. This tells you how does this particular Pokemon perform against a fairy type Pokemon. So these are general ratings which you can find over here. Then you have the special attack and special defense of the Pokemon over here. Then you have the speed of the Pokemon. Then you have type 1 and type 2. So type 1 is the primary type of the Pokemon. So this is the Pokemon over here. The primary type of this is grass, and the secondary type over here is poison. So this is a grass poison Pokemon. And then we've got the weight of the Pokemon in kgs. Then we've got the generation. So to which generation does this Pokemon actually belong to? So there are 7 or 8 generations in total, I believe. So you have all of those numbers or generations marked over here, and then finally we have the S legendary column. So this S legendary column tells us if the Pokemon is legendary or not. So if the value is 0, then that would mean that the Pokemon is not legendary. On the other hand, if the value is 1, then that would mean that the Pokemon is legendary. So this is some basic information about this data frame which we have just loaded. Now, since we have to make a bar plot, and a bar plot is made on top of a categorical variable, so we'd want to understand the distribution of this is legendary column. So I'll map S legendary onto the x-axis, and onto the y-axis I'll map the speed column. So here I'll type in sns.barplot, and onto the x-axis I would have to map. So let me check the whether it is in small letters or capital. So this is legendary, and then onto the y-axis I will map the speed column, and onto the data I'd have to map Pokemon. This is done, and then I'll just type in plt.show over here, and this is the result which we get. So 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary, and you guys can clearly see that the legendary Pokemon seem to have a higher speed when compared to non-legendary Pokemons. So this is what you see, this is the maximum value. So it seems like there is actually one legendary Pokemon whose speed is almost equal to 100 or near to that, and then the maximum speed value for a non-legendary Pokemon seems to be around 62 or 63. So I'll just go ahead and look at some more questions. SI is asking, is read CSV file function not available in Seabourn? So read CSV is a part of the pandas library. So again, when you're mostly dealing with data frames, you would have to use the pandas library. So the load data set. So in the earlier example, so if I believe most of you guys would have this doubt. So over here, we have used this load dataset method because fMRI dataset is a part of this Seaborn library. And since this is a part of the Seaborn library, I have used a method load dataset, which again is a part of the Seaborn library to load this dataset. But to load any other dataset, which is not part of any of the libraries. So if you have to load external datasets, right? So you have a lot of external datasets. Now, if you have to load those external datasets, you would require the pandas library. So first you'd have to import pandas, and there is this read underscore CSV method. So by using pd.read underscore CSV, you are able to load this file. And what I'm doing is I'm just storing this into a new object called as Pokemon. So I hope that answers your question. Paris is asking, what is the box plot representing over here? So Paris, this is a bar plot, not a box plot. So we will also create a box plot in a few minutes, but what we've created for now is actually a bar plot and not a box plot. Akshay Pawar is asking, is data visualization required for a data scientist? Absolutely. Data visualization is a very important skill set in a data scientist repository, and I say that because let's say you would personally you would as a data scientist you would have the technical expertise to interpret the results, but those results, so if you have to show those results to your stakeholder, or if you'd have to represent it to your client, then the stakeholder or the client would not be able to interpret those technical results very easily. So this is where data visualization comes in. So again, data scientist, the job role involves understanding the data, analyzing the data, and showing the results in the form of basically showing the results so that everyone can understand the data. Because in the end, it's the stakeholders or the clients who will be using the information from the data, isn't it? So once you have the results from whatever analysis you've done, you'd have to show those results in the form of beautiful graphs. This is where you use different visualization libraries. So let's say if you've implemented that in Python, then you can use these libraries such as matplotlib and Seabourn. So similarly, if you implemented it in R, then you can use libraries such as ggplot2 and ggvis. And also you can use BI such as Tableau, so you can create really beautiful dashboards with Tableau. So simply put, data visualization is very important when it comes to a data scientist job profile, because in the end, the results which you get as a data scientist, they have to be shown in the form of beautiful graphs to the stakeholders or to whoever is making the decisions. Praveen is asking, where is Pokemon.csv stored? So Pokemon.csv is an external data file. So I had this data set downloaded from Kaggle. So if you want this data set, you guys can get it from, so you would have the link for, the PPT and the code file and also the data sets on in the chat. So you guys can click over there and you can find it from there. Wasim is asking us to create a video on Ruby. So right now we are not really focusing on Ruby, but we'll note it. So we'll see if someone from our team can go ahead and make a video on Ruby. Shubham Kundu is asking, can you tell best resources or any website to learn data visualization? So if you're talking specifically about Tableau, then we've got this really good video by Professor Vivekananda. So we've got this Tableau tutorial by him. You can check that out on our YouTube channel. So that video, so that will tell you, it will mostly cover all of the basics of Tableau. It will tell you how to create a dashboard and how to work with different graphs. And also, Professor Vivekananda, he has his master's degree from Monash University. So he has really good expertise when it comes to Tableau. You guys can go ahead and check that out. Shubham is asking, can I share a whole path to become data scientist from scratch? Sure, we'll have a session on that as well. Right, so keep posting your questions, guys. I'll go through most of your questions. And yeah, so if you, again, to inform you guys, if you don't really know what exactly is Great Learning Academy, please go ahead and check that out, as we are offering more than 100 courses, and those courses are with respect to different domains. So it's not just limited to data science or AI. We've got courses with respect to cloud computing. We've got courses with respect to digital marketing, statistics, full stack development as well. And most of these courses are by professors who have their PhDs from either Stanford or other Ivy League schools. And we've got other courses as well where the professors are from IITs and NITs. So you can learn really high quality stuff from these esteemed faculty members. And the best part is, once you complete these courses, you'll get a certificate as well. So that'd be some, either you'd have to complete either some quizzes, assignments, or projects. So once you complete them, you will have the course completion certificate, and you can go ahead and add it onto your LinkedIn profile. And now also, as I've been telling you guys, we also have this app, the Great Learning app. You can check out the link for the Great Learning app in the description over there. So also you can share the link of the app with your friends, and especially in this lockdown, I believe most of you would want to be productive. So so you can spread the word of mouth to your friends, to your colleagues, to your peers, and let them know that we are providing all of this high quality stuff for free, and you can and they can check out Great Learning Academy or the Great Learning app. And also do subscribe to our channel, and also tell your peers to subscribe to our channel, as that will encourage us to come up with more such sessions. Right, so now that we have done the bar plot over here, now what we're going to do is we'll see what else can be done. So in the earlier example, we had mapped the S legendary column onto the x-axis, speed onto the y-axis. Now we're going to do just a minor change over here. So onto the x-axis, we have mapped the S legendary column, and onto the y-axis, we've mapped the weight in kg column. So the categorical column remains the same. It's just that the numerical column which we've mapped on the y-axis, that changes over here. So here we are trying to understand what is the difference in weight of a legendary Pokemon and a non-legendary Pokemon. And as you guys over here, it is very evident again that legendary Pokemons have a very high weight when compared to non-legendary Pokemon. So as you see over here, non-legendary Pokemons, at max, the maximum weight of a non-legendary Pokemon seems to be around 50. But if you look at this, the maximum weight of a legendary Pokemon seems to be more than 250 kgs. So this again is a very interesting observation, isn't it? So here what I'm going to do is I am going to cut this out, and I will paste this over here. And instead of having the speed column over here, I'll map the weight in kg. So I'll just set this to be weight in kg and let me click on run. And as you see, this is the result. So we've got S legendary on the x-axis, we've got weight and kg on the y-axis. So this was a simple bar plot. Again, now since we want to do, since we actually want to complicate this plot, because that is what most of the data scientists do, to try to understand complicate stuff. This time what we are doing is we are mapping the generation column onto the hue aesthetic or hue attribute. And since there are 7 generations, that is why we will have 7 bars with respect to each category. So we've got these two categories over here, not legendary and legendary. And for both of these cases, I'll have 7 bars. So over here, these 7 bars indicate the 7 generations of the Pokemon. Right, so over here, this purple or violet, so I'm not really good at colors, I'm calling it purple over here. So if the bar is purple, then this belongs to generation 1. And again, this seems to be a shade of pink. So if this is of pink color, then this belongs to generation 7. So these are the different bars indicating Pokemons of different generations, and we've got the same sequence over here. Now let's try to draw some inferences over here. So if we look at these, then it seems that if the Pokemon is not legendary, then the Pokemon belonging to generation 1 seems to have the maximum speed value, and the Pokemon belonging to generation 2 and maybe generation 7 over here has the lowest speed value. Similarly, if we look at this over here, we have the same sort of inference. If the Pokemon is legendary, then Pokemons belonging to generation 1 have a very high, have the maximum speed value, but Pokemons belonging to generation 7, they have the lowest speed value. This again is very intuitive because as we had seen in the earlier graph, so the weight of the legendary Pokemons or weight of Pokemons belonging to generation 7, it was higher, and that is why Pokemons belong to generation 1. So if you had seen the Pokemon series, then you know that in generation 1 we had Pokemons in their earlier stage. So let's say if you take Pikachu or Bulbasaur or Charmander, then all of them were in their early stage. So again, since their weight was very low, and that is why their speed was very high. So interesting observation over here again. So I'll just use SNS dot bar plot over here, and onto the x-axis I'd have to map S legendary. So I'll just type in S legendary over here, and onto the y-axis I'll go ahead and map the speed column, and I am just adding a new attribute called as hue, and onto the hue attribute I will be mapping the generation column. So we've got 7 generations of Pokemons, and onto the data layer I'll be mapping the Pokemon dataset, and here I'll just use PLT.show. Let me click on run and let's see what do we get. So as you guys see over here, we've got 7 bars with respect to both of these categories. Right, so this again is quite interesting. I'll just look at some more questions. So Priyanshu is asking, what project should we choose on Kaggle to start with? So there's this Titanic data set. So everyone, if you're a beginner, so I'm just assuming that you're a beginner in data science. So most of the folks who start with data science, there's this common data set called as Titanic data set, and you can go ahead and check it out and start with it. So there, let's say if you initially you rank it, maybe when you submit the result, maybe you will I believe there'll be more than lakhs of submissions right now. So initially when you submit, you'll be somewhere around 50,000. So try to get that result up. So try different combinations of models, try to pre-process the data and try to get it to maybe within the top 10,000 ranks. Now these ranks are with respect to, so these are worldwide ranks. So when I say in top be in top 10,000, so if you are in top 10,000, and so these are that is a rank with respect to the entire world, and that is actually a really good achievement. So try and go ahead and work on these. Okay, so Sohan is saying I already completed the data analytics course, but I'm confused. What is the skill needed? Someone says machine learning is needed for data analyst. What do you say? Which skill is needed? So when you talk about, so normally in industry, these terms are a bit interchangeable. That totally depends on what that particular company or that particular industry is doing. So the data analyst role or the data scientist role sometimes are very interchangeable. But in general, what happens is when it comes to data analyst roles, the data analyst roles are mostly dealt with pre-processing. So when you talk about data analyst, there's not much of, so I'd say 70% of your time will be dealt with understanding basic insights and working with tools such as R and Excel. So at least most of the data analysts which I've come across, so they either work on Excel or R, and what they do is they do basic pre-processing, they do basic data manipulation, data visualization, and they try to convert the raw and structured data into a data which has a tidy, proper structure. So that is what a data analyst does. But when you talk about a data scientist role, a data scientist is someone who uses this tidy data prepared by the data analyst and uses it to find some find some more new insights. So let's say a data scientist goes ahead and tries to predict something from the existing data, or he tries to classify something from the exist data. So this is the broader differentiation between a data analyst role and the data scientist role. And when you talk about deep learning, so deep learning is something where for the role you'd have to use deep learning frameworks, and you'd have to work with neural networks in general. So you'd have to work with recurrent neural networks, convolutional neural networks, and you'd have to use deep learning frameworks such as TensorFlow, Keras, and PyTorch. Right. So Koribili Raju is asking how to submit assignments. So that I'm not really sure. So you can actually, so I believe there's, if you have any doubt, there's a system to raise a ticket on Great Learning Academy. So you guys can maybe raise a ticket if you're not sure how to submit the assignment. So the team which is handling Great Learning Academy can help you out immediately. Right, so we have implemented this bar plot over here. Now that this is done, what we'll do is we'll just try to play around with the color of these bars over here. So we have this attribute called as palette. So here we are using three different types of palette. So let me show you guys the earlier image. So this is what we had. So by default, we had this blue and orange color. Now, if I don't want that blue and orange color, if I want a different palette, then we have to use this new attribute called as palette. And you guys can check out these palette colors on the official Seabourn, Seabourn sites and see what are the different palettes available. So here, the first palette which I'm using is Blues D. Here you have to keep in mind that B is capital. If you given B as small, then you'll get an error. So when you have the palette as Blues D, this is how the bars will look like, or this is how the colors of the bar will look like. Then we have this palette called as Rocket. So this is the color which you get with Rocket, and this is VLAG, and this is what you get with VLAG. So let's go ahead and work with those. So I'll just copy this over here. I'll paste it, and let me add in this new attribute called as palette. So I'll have palette over here, and initially I'll map this color called as Blues D. And let's see what do we get. So as you see, this is the palette color which we have added. Now similarly, let me go ahead and change this to Rocket, and we have changed the color again. Now let me go ahead and add VLAG over here, and as you guys see, I have changed the palette color of the bars again. So this was again some very basic stuff. Now let's say instead of changing the color or mapping a column onto the color aesthetic, what we're going to do is we are arbitrarily going to set a color. So for this, all we have to do is use this attribute called as color, and I am mapping orange onto this, and as you see, this is what we have. So here I'll just remove this palette attribute from this, and I have color over here, and I'll go ahead and map. So let's say instead of orange, I'll maybe have yellow. So I'll see we have yellow, so both of the bars are indicated by the yellow color. Similarly, let me make it green, and as you guys see, both of the bars are indicated with the green color. So that was a bar plot. Now we'll head on to the next graph, which would be a scatter plot. So scatter plot again is something which is used to understand the distribution between two numerical values. So when I say numerical values, it is basically a continuous numerical value, and for that purpose we'll be working with this iris data frame. So this again is an external data frame, so is a very commonly used data frame, and if you want this, you can go ahead and check out the link in the description. You can find this dataset from over there. And what I've basically done is I have already loaded this dataset onto my Jupyter notebook, and to work with this I will have to use read_csv from pandas, and I have loaded this file and I have stored this in this object called as iris, and then I just have a glance at the head of this. Now I believe most of you folks have worked with this data frame, but to some of you people who haven't seen this data frame yet, so this iris data frame is about the iris flower, and this iris flower has three different species, which are Setosa, versicolor, and virginica, and this is about the different features of the species of the flower. So you're trying to understand about the relation between the sepal length, sepal width, petal length, and petal width of the different species of the iris flower. So now that is clear, here as you see we've got four continuous numerical variables, and we have one categorical variable. And since we have to make a scatter plot is used on top of continuous numerical variables. So here we are mapping the sepal length onto the x-axis, and we are mapping the petal length onto the y-axis over here. So sepal length, as you see, this is the column, I'm mapping this onto the x-axis, and petal length, this is the column, I'm mapping that into the y-axis. So this is what we have, and as you clearly see, as the sepal length of the flower increases, the petal length of the flower also increases. There is sort of a linear relationship between these two variables, and the data which I'm using, or the scatter plot which I'm making, is on top of this iris data set, and I go ahead and show this out over here. So let me load the dataset first. I'll use pd.read_csv, and in this I'll just type in iris.csv, and let me go ahead and store this in an object called as iris. And let me show you guys the head of this data frame. So as you guys see, this is the result, and now I'd have to make a scatter plot. So to make a scatter plot, I'd have to type sns.scatterplot, and onto the x-axis I'll just go ahead and map sepal length. So I'll have sepal length over here, and onto the y-axis I'll map petal length. So I'll just type petal.length, and the data which I'm using is iris, and then I just have to show this out, and let me click on run, and let's see what do we get. So this is the result. So sepal length on the x-axis, petal length on the y-axis, and as you guys see over here, there is sort of a linear relationship. So if the sepal length of the flower increases, the petal length of the flower is also increasing. Let me just go ahead and look for some more questions. Is Excel required for a data scientist job profile? This is asked by Akshay. So I'd say you would need a basic expertise with respect to Excel, but in most of the data analyst jobs, so let's say the tasks which you can do with Excel, most of those tasks can be done with either R or Python, and also it's much more easier to implement those tasks with R or Python. So I'd say if it's a data analyst role, then I'd say you would have to have more knowledge of Excel. But if it's a data scientist role, then I'd say focus more on R rather than Excel. Anup is asking, can you use color to distinguish the species on the same plot? Yes, we can do that. So we'll just go ahead and see how we can do that. Right, so I'll just answer Anoop's question and show that. And since we're also done with the time, so I'll just answer this question. Again, all we are doing is using hue. And as we've already seen, with the help of hue, we can assign a color. And I'll go ahead and map the species column onto hue over here. When I click on run, as you guys see, we've got three different species, which are Setosa, versicolor, and virginica. These blue color markers are denoted by Setosa, these orange color markers are for versicolor, and these green color markers are for virginica. And it is very evident that the virginica species, they have the maximum sepal length and the maximum petal length. And when it comes to Setosa, these Setosa species have the lowest sepal length and the lowest petal length. Alright, so this is how you can add different colors with respect to different species over there. Right, guys, so I believe I've covered most of your questions, and we're also done with the time. So before I sign off for today, I'd like to inform you guys again that if you guys haven't yet checked out Great Learning Academy, go ahead and check that out. So we have a lot of free courses over there, and all of those free courses have been taught by industry experts or top rated academicians in the field of data science. So we've got professors such as Dr. Abhinanda Sarkar, we've got Dr. PKV, we've got Dr. Muthuraman, we've got external faculty such as Vivekananda. So all of these are high profile esteemed academicians, and they've got easily more than 10 years of teaching experience. And when you complete these courses, you would have to either submit the assignment or the quiz, and you will get the course completion certificate. And also, if you want to learn through an app, you will find the link for the app in the description, so you guys can go ahead and download the app as well. And also just go ahead and subscribe to our channel and hit that bell icon, as that will encourage us to come up with more such sessions. And also spread the word of mouth about Great Learning Academy and also about Great Learning's YouTube channel, because we believe in giving high quality knowledge to everyone across the world, because not everyone can afford these high quality lectures for free. So if you know any of your peers or your friends or colleagues who is looking to venture into the field of data science or cloud computing, you can tell them about Great Learning's YouTube channel, and you can tell them about Great Learning Academy and how they can upskill in this time of lockdown. So guys, that'll be it from my side. Thank you very much for attending the session. Stay safe and keep learning.